Anybody there?
Huh?
Is that you, Charles?
It is, maybe. Who's asking?
It's me, Michael. I was going to do another lesson.
Ooh, I like lessons. How you doing, Michael?
Yeah, I'm doing all right.
I noticed that my favorite letter is on the screen.
Yes, Charles likes the C.
Yes.
C, senor. Yeah, so remember we had a lesson that was triple A, so this is the triple C lesson.
That makes sense.
I don't know if it makes sense.
What about the triple B?
Triple B happened, but you have to pay premium rates to see that one.
Nice. We quadruple your tuition.
No, there's no triple B at the current time, but we can think about that for later.
Maybe for our third class.
So let's see. So we talked about game theory, and one of the cool things about game theory is it let us reason about sequential decision making and agents and learning in the context of there being more than one of them in the world.
Right.
So this is something that I wrote in my dissertation, is that in some sense MDPs are very solipsistic.
Wow. Did you actually write that?
I did. It's in my intro. Do you know the word?
Of course I do.
Okay. Do you want to define it for everybody?
No, because that actually would be ironic.
Okay, fair enough. So the idea of solipsism is that you're the only thing in the universe, and everything else is just, kind of there.
Yes.
But you're the only real thing. And so one nice thing about the game theory setting is it actually lets us admit that maybe we're not alone. So what I'd like to do in this lesson is actually dive in even more deeply to that idea and talk about how the MDP, or the Markov planning and learning type framework, can be adapted to be able to talk about coordinating between agents, communicating between agents, and actually coaching between agents.
That sounds perfect. That's actually the kind of thing that I like to do and I like to think about as part of my research. So I am looking forward to learning more.
Excellent. So the way we're going to do that is actually look at different ways that Markov models can be kind of modified and redefined so that coordination and communication and so forth is a natural property in the model. And we'll look at a couple different models. The first one is called DEC-POM-DPs, and the second one is called inverse reinforcement learning, and they kind of get at these different issues in slightly different ways.
Good. I think. Well, we'll do that. We'll talk about it some more later.
Okay.